numbers are always being a part of your syllabus since you were in your primaries, right? Like addition of numbers, subtraction of numbers, right? So in this lecture particularly, we are going to see what are actually different kinds of number system. Then we are going to see the convergence from one number system into another number system. Okay. So the very first number system is a decimal number system. This is the most common number system which all of us are being using since our childhood. Okay, it is called decimal number system because it is having a base of 10. Okay, next is a binary number system. Okay, here binary number system means what? It is a number system which is having a base of 2. Bi means what? 2. So it is having just base of 2. It is going to have only 2 digits as zeros and ones. Okay, decimal means it is going to have the base 10, means it is going to have the combination of 10 different digits, that is from 0 to 9. Okay, from 0 to 9, so it is going to state as a 10, right? Same way, next is a octal number system. Now this octal number system, basically this octal number system has a base of 8. Okay, but it is going to start from 0, so it will continue till 7. We are going to see all these number systems in detail. Just I am giving you a brief introduction of all the number system. Next is a hexadecimal number system. This one, a hexadecimal number system is having a base of 16. Okay, so it is going to start from 0, so it will continue till 15. Okay, so we are going to see all these number systems in detail, and also the conversion of numbers from one system to another system. That is the conversion from decimal to binary, binary to decimal, or binary to octal, octal to binary, hexadecimal to octal, octal to hexadecimal, and so on. So in this lecture we are going to cover only this decimal part, and in next lecture we are going to see all these conversions and all those part. So let's start with the very first number system, that is a decimal number system. Okay, so very basic. This is a bit introductory part, but this is required in order to get you people acquainted with what actually is a decimal number system. Okay, so the word decimal is a derivation of a word decim. Okay, and this word decim is nothing but which is a Latin word for 10. Okay, 10. Already I have told you that the base for this decimal number is 10. So why it is 10? Because the word decimal is derivation of decim, and in Latin this decim is nothing but 10. Got it? How the base 10 is there for decimal? Okay, and next thing it states is that numbers today are almost universally written in a form of notations known as positional numbers representation, right? Positional number representation. We have people have already seen this positional number representation when you were in a school, right? That is the zeros, units place, tens place, hundreds place, thousands place, 10,000s place, right? So these are nothing but positional numbers. Okay, whatever numbers we people are using, all are positional numbers, right? Units, tens, hundreds, thousand, 10,000, lakhs, 10 lakhs, in this way. Okay, so same way decimal numbers are also a positional number representation. Fine. Next is that a number is represented as a string of digit. String of digit means what? If I want to represent 1245, so how I will be writing 1245, 1, 2, 4, 5, right? Means what? It becomes a string. I'm writing it all together, right? I'm not writing 1245. I'm not representing the number in that fashion. When I'm writing it normally, I'm writing it in the fashion that 1, 2, 4, 5. Means it is a string of digits, right? Now, next thing is that in decimal number, there are 10 such digits that may be used ranging in the values from 0 to 9, right? Means what? We can use only these combination, or we can use a combination only of these numbers which are ranging from 0 to 9. It can be anything. See 1, 2, 3, 4, 5. It is also a combination of 0 to 9. So this is also a decimal number, right? If I am saying 5, 7, 8, 9. So this is also a combination of 0 to 9. So very beginning only of this lecture I told you that the decimal numbers are the numbers which we people are using in our regular life. Okay, whatever number system we are using is nothing but a decimal number system. Okay, so it is obviously the combination of 0 to 9 numbers. Okay, then the decimal numbers are positional numbers that have a base or radix of 10. Already I told you that it has a base of 10, but how it is going to be represented, that we are going to see in the upcoming slides. Okay, now a very big question is that why 10? Why it is having the base of 10? Okay, because already we seen that it is, the name itself represent that decim is nothing but a Latin word for 10. So that is the reason why it is having the base of 10. Now we are going to see one example, short example, based on which you people will understand how it is actually going to work. Okay, so see, exactly 10 distinct numbers in order to represent Means what? In this decimal number system, there is exactly 10 distinct numbers in order to represent all the possible values of each position in the number. See, 10 numbers, that is from 0 to 9 numbers, okay, in the number, and hence enables us to represent all possible integer numbers in decimal notation only. Okay, so for representing we are going to use only the combination from 0 to 9, that is nothing but 10 numbers will be used for this purpose. Okay, so you have taken a small example over here, as you can see. For example, number like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, even this combinedly is also one number, isn't it? So it is nothing but it has a 10 positions, and each position can contain the digits from 0 to 9. How many positions are there? Units, tens, hundreds, thousand, 10,000, lakh, 10 lakhs, okay, and so on. So there are 10 different positions, right? And each position, it can contain any combination of numbers from 0 to 9. Okay, it is not necessary that here it has to be 9 only. Here it can be 1 also. It is not necessary that it has to be 8 only. It can be 2 also. It is not necessary it has to be 7 only. It can be 7, 8 also. Okay, so it can be any combination of digits from 0 to 9. Okay. Now, each digit position has a weight associated with it, right? Whatever digit is there, every digit has some weight associated with it. As I already told you that tens units place is nothing but it has nothing associated with it. Tens place means what? It will be having 1 0 associated with it. Hundreds place means what? It will have 2 0 associated with it. So what is this? All these are nothing but the weights associated with each position of a given number. Okay. Next is that each digit corresponds to a power of 10 based on its position in the number. Okay, 10 based on its power or position in the number, that we are going to see with the example. Now, how is the numbers weight computed? How is the numbers value? Numbers value equals to a weighted sum of the digits. Weighted sum means what? That we are going to see. So a number value is nothing but sum of all the weights of each and every individual digits within the number. Okay. So this is a small example representing this concept, that is numbers value equals to a weighted sum of the digits within a number. So you can see over here, numbers value equals to digit into 10 raised to x plus digit into 10 raised to x plus digit into 10 raised to x and so on, where x is nothing but position number minus 1. Why it is minus 1? Because see, it is going to start with unit, and with unit there is nothing associated with it. Whenever we are talking about unit, that 10 raised to it will be 0. Okay, whenever it will be tens place, it will be 10 raised to 1. When it is going to be hundreds place, it is going to be 10 raised to 2. When it is going to be thousands place, it is going to 10 raised to 3, and so on. So the position number minus 1 is done. Okay, the power of 10 increments from 0, 1, 2, etc. as we move from right to left. Okay, this already I have told you. So this already it is discussed previously only. Units, tens, hundreds, thousand, 10,000, lakhs, and so on. Right. So units place, it is going to be start from say right to left means what? It is going to be 0 here. Tens place it is going to be 1 over here. Hundreds place is going to be 2 over here. So powers are going to be incremented from 0 to so on, moving from right to left. Okay, so we'll see a very short example dealing with this. So this is a very simple example I have taken for representing a decimal number. Okay, see, the base is 10 or des or simply d. It can be represented as d, it can be represented dec, it can be represented as 10, and all these three represent the same thing. Whenever you see into bracket some number is given and on the right hand side base to it, suppose d is given, you have to recognize that this is a decimal number. Or in a bracket, if suppose a number is given and on the right hand side bottom to it 10 is written, and you have to understand that this particular number is a decimal number. Okay, so this is nothing but a notification for a decimal number. Okay, so already I have told you that base is nothing but 10, right? So here I have taken one number, that is 10 raised to 3. 10 raised to 3 it represents nothing but 1000. 10 raised to 2 it represents 100. 10 raised to 1 it represents 10, and 10 raised to 0 it represents 1. So how this is represented? So 10 raised to 3, this is nothing but power of an exponent. 3 is nothing but a power and base is 10. Okay. Now this particular number is a decimal number. Which number? 1, 2, 3, 4. This number is a decimal number. How it is a decimal number, or how confidently I can say that this is a decimal number? The reason that I can say this is a decimal number, because it is having the base written as 10. Already I have told you, it can be brackets over here or it can be without brackets, but if it is 10 over here, it is a decimal number. Okay, or if it is DEC over here, still it is a decimal number, or if it is written 10 over here, still it is a decimal number. Okay, but how these decimal numbers are formed? Already we have seen it, how the weights are computed for each of them. Okay, so see, we are going to start from right hand side. 4 into 10 raised to 0. What is stated? As you can see over here. Here over it is in power of 10 increments from 0 to 1, 2, 3, 4, 5, 6, etc. And we are supposed to move from right to left. Right? We are supposed to move from right to left. So see, this is our right hand side, this is our left hand side. So whenever we are moving from right to left, the power is going to increase. Initially, when it is the rightmost element of the digit, 4 is there, right? So 4 into 10 raised to, what is the power? 0. Because it is the rightmost element. Already I have told you, units place is always represented by a power of 0. Okay, then it is a tens place, right? So 3 into 10 raised to 1. See, the next digit is there on the right hand side is 3. So 3 into 10 raised to 1, right? Next digit is 2. So 2 into 10 raised to 2, right? So the power is increasing. If you can see 0, 1, 2, 3. Okay. So if you perform this computation, it together will give you 1234, right? So you are supposed to compute this on your own. What is the power of 3 means what? 1000, right? 10 raised to 2 is nothing but 100. It is 10. So how it becomes 1000, as it is 3 zeros, 1000, 2 zeros will be there. So 234. Okay. So this kind of number is nothing but a decimal number. I hope it is clear to you people what is a decimal number. Okay. See here. Already given. 1000 for this, 200 for this, because multiplication will give you this 30 and 4. That finally will give you 1234. Okay. I hope it is now clear to you people how a decimal number is represented and how or why it is called as a decimal number. Okay. Second example we'll see. See, in previous example what was taken? I have taken the base as 10. Right. In this example I am taking the base as D. It is not going to make any kind of difference. As I already have told you that it can be 10, it can be DEC, or it can be D. In all cases the number is going to be decimal itself. Okay. So see again. It's 10 raised to 0. So it is going to be 1. Anything raised to 0 is 1. So 6 into 1 is going to be 6. Then 10 raised to 1, it is going to be 10. 7 into 10 is going to be 70. Same way, it is 10 raised to 2, it is going to be 100, right? So 8 into 100, it is going to be 800, right? Next is 10 raised to 3, it is going to be 1000. 9 into 1000 is going to be 9000. Okay, and if we combine together, it is going to give you the original number, that is 9876. Okay, so we have completed the concept of what is a decimal number, how it is actually represented. Now what are the different bases which are going to represent a decimal number, and most importantly that whatever number system which we are using in our mathematics daily, that is nothing but a decimal number system. Okay, so it must not be very difficult for you people to digest this concept because you are using this since your primaries. Okay, now summaries is nothing but what we have seen in decimal system. There are 10 digits only, and that 10 digits, it doesn't mean that there are 10 digits only. It is nothing but combination of 10 digits. Okay, it can be any digit, but it should be the combination from 0 to 9 only. Okay, which combine to form a number as follows. So this combinedly as a whole, I can say this is a decimal number because it contains the combination of digits from 0 to 9 only, and not more than that. And in fact, there is nothing more than that also. Okay, so at the very beginning, what I have told you, that it is a natural number which we people are using daily. Okay, because we are using the same number system. Every number gets covered in whatever number system we people are using. That is nothing but every number gets covered in the number system called as a decimal number system. Okay, so I hope you people got the concept of what is a number system and what is a decimal number system. Okay, at the very beginning we saw all these things, that is a decimal number system, binary number system, octal, what base they people these number system are having. Okay, and we see from where that word decimal has been derived. It is a Latin word which means 10, so it is having the base of 10, right? Then we have seen how many numbers are there. There are 10 different numbers, but as it is starting from 0, so it is going to continue till 9. Okay, next is that what actually the number's value is. That is, it is nothing but a weighted sum of all the digits, and we have seen the examples also for weighted sum of the digits. This is the example for the weighted sum of digits, right? So in this way we have covered the concept of what is a decimal number system. Okay, so in next lecture we are going to see what is a binary number system. Okay, binary is, already have told you, it is a base of 2, and this binary number system is nothing but, already we have seen our computer system works in a binary system. So give your main focus on a binary number system. Binary means what? By only two numbers will be there in binary, that is 1 and 0. Okay, nothing will be there apart from 1 and 0. Everything, your decimal will also be represented binary in zeros and ones only. Okay, no other number apart from 1 and 0 will be included in the part of binary. Okay, so we'll cover it in next lecture. For now, thank you.